Thank you. Okay, this is the page I assigned unto y'all for homework. Here are the answers to that page. Take a look at questions 1 through 16. Are there any comments, questions, concerns? Is there anything anyone would like me to go over? Yes. Number 13.
Number 19.
19 is not even on the screen yet. How do you got it wrong?
I already have that.
Oh, you haven't done it yet. Okay, I will do that. Sure, I can go over 19, but I haven't given you the answer yet. So let's take a look at that first. Are there any questions 1 to 16 anyone wants me to go over? Yes, Pavneet.
Go over
Number 10. Yes, I can go over number 10. Are there any other questions anyone would like me to go over questions 1 to 16? Yes, Manraj. 12. Yes, I can go over number 12 as well. Are there any other questions anyone would like me to go over? Guntas. 16. Did you do 16? Well, no. You have to try it.
Never mind, I figured it out.
What number did you ask for that you don't?
It was number 10. I forgot to cancel. I forgot to.
Okay, no longer doing question 10. Okay, who else? Anything else 1 to 16? Okay, here are the answers for 17 through 22.
19.
Okay, so right now I'm doing 12, 16, and 19 in a second. Number 22, these are 3 different totally acceptable answers to that question. Any one of those 3 is acceptable. Yes, Pavneet.
Go over
Number 11.
Yeah, I think I did.
No, I'm going to go over number 12. 11's basically the same thing. 11's really easy.
I got no.
Okay. Anybody else? 17, 18, 20, 21, or 22. Is there anything there anyone wants me to go over?
Never mind, I got number 11 too.
Yeah, good. I wasn't going to go over it anyway. But I'm glad you figured it out. Okay. So, we're good with some... You're asking me about 12, 16, and 19, but no one's asking me about 20, 21, or 22? Like, those ones are terrible compared to the 3 you're asking about.
Still checking them.
21?
It's not 19.
Not 19.
Yeah.
You're cool with 19?
Yeah, kind of.
Are you cool with 19 or not?
Kind of.
Oh, you'd be kind of cool with it.
Like I got it, but it's different in a different way. Not with the laws.
I mean, either one of these are correct.
I got one to you.
1 over 2 you. You got the blue one? Yeah, then you're good. Anything that has answers in multiple colors means any one of those colors is an acceptable final answer.
So you don't have to worry about a law. You didn't do it with the law.
I mean, I did this one with the laws, and this is what I got. As long as your work makes mathematical sense, you're good. Either of these is good. So maybe I should have said that. Any one of the different colors answers are all equivalent. You have one of those, you're good to go. Yes, Pavneet.
I basically got like all 6 questions at the bottom wrong.
You got all 6 questions at the bottom wrong. 17, 18, 20, 21, and 22. Okay, here we go. Let's go over some of these. Number 12. Okay, who am I talking to? Who wanted 12? Manraj. Okay, Manraj. So how did you start?
I did, so, you know, I did 8, 3, 8. I did, so did 8, times 8, times 8, times 8, and then I did, oh, no.
Okay, we gotta whisper. We gotta learn how to whisper. Geronimo, we gotta talk quieter, or better yet, not at all. Okay, so exponent laws. I want you guys working with exponent laws. I don't want you expanding everything. When there's no exponent written, the exponent is assumed to be a 1. And now let's deal with the bottom here first. The exponent law says when I multiply the same bases, what do I do with the exponents? When I'm multiplying the same bases, what do I do with the exponents? Add them. The bases are being multiplied, I add the exponents. So I'm going to get 8 to the 3 over 8 to the 4. What do I do when I am dividing? What's the rule for division of same bases? I subtract exponents top minus bottom. 3 minus 4 is? So it's going to be 8 to the negative 1. That's one way to do this question. Another way to do this question would be like, okay, let's write it out again. 8 to the 3 over 8 times 8 to the 3. What happens when you divide something by itself? It's 1. So what's left is 1 in the numerator over 8. These two are equivalent. Either one of those answers is acceptable. Manrar, does that make sense? Okay. 16. Who wanted 16? Guntas. Didn't even try it. Here we go. So Guntas, based on what I just did with number 12, do you have any thoughts of where we could go with number 16? On what? On, don't say, did you say the things? What base? X squared. Okay, so x squared, what do you want me to add that to? What exponent am I adding to that? Sorry, what? It has x, there's x squared. There's a 2 there. So now what am I doing? What other exponent? I don't see a 3. What one? I also don't see a 1. No, you got this, man. Keep going. Yeah, but x and 3 are not the same thing. I can only combine exponents if the bases are the same. Is there another x base somewhere in that numerator? Yes. Yes, there is. It's right here. And that guy has an invisible 1 on it that you mentioned earlier. So these are the 2 bases I can group. What is 2 plus 1? So I'm going to get an x to the 3 up there in the numerator. I haven't done anything with that x squared. And when there's numbers and letters, you can just multiply the 2 and the 3 together. 2 times 3 is 6. Cool. Keep going, Guntas. What can I do now? Which ones? How do I subtract them? You betcha. That's going to give me done, which is just 6x. Beauty. See, you didn't need me. Okay, 17. So again, we don't have a ton of time. So I'm going to crank out 17. Here's how I would do 17. I would say, first of all, that I'll do what Guntas did in the previous one. I got 2 n's multiplied together in that numerator, so this is going to become 3n squared. And on the bottom, I have a 3n squared I haven't touched. Oh, look, 3 divided by 3 is? 1. N squared divided by n squared is? 1. 1 times 1 is? Done. Number 19. Sorry, what? Pavneet asked for all of the last 6. Because she did them all, but she says she got them all wrong. So I'm going to do 17, 19, 21, 18, 20, and 22. I'm just going to crank them all up. This one, similar to how I did this guy up here, the green one, I'm going to make some cancellations here. Do I have anything that shows up in the top and the bottom in number 19 that cancels, gives me 1? Does the same thing show up top and bottom anywhere? Pavneet? The U? Well, no. Look at this. Go back to the TV. Look at the TV. Do I have the exact same thing anywhere, top and bottom? Yeah, I got 3. 3 divided by 3 is? 1. Gone. Do I have anything else? Manraj says yes. Okay, Sahib, pay attention. Manding, pay attention. Manraj, what else do I have? Nope. I only have a u in the bottom. Pevneet.
Power of 2.
U to the power of 2. Yes. I have a u squared and a u squared. Bam. Bam. They divide away. Give me 1. You have to have the exact same thing. Do I have any other same thing top and bottom? Pevneet.
The B's
Boom. Boom. When I divide everything out of the numerator, what has to be left up there? A 1, someone said. Okay, Geronimo. I'm talking over you the whole time here, man. Unless you're helping her with the question I'm working on, please stop talking. So I've got a 1 left in the numerator, and in the denominator, I've got a 2u. Because nothing's happened with that yet, and we're done. 21, same thing. Do I have anything top and bottom? Manraj? U to the power of 2, u to the power of 2. Shows up in the top and the bottom. Deal with it. Yep. I have a v and a v. Anything else? Okay. Is there something left in the numerator? Yeah, a 3. So I don't have to toss the 1s up there because there's still something there. So I've got 3 over uv and we're done. That was the answer on my page. Benita, does that make sense?
Yeah.
Did you do it a different way?
I did cancellation.
Did you? Oh, so you got the same thing I got. Okay. Yeah. For number 20, I got 3xy squared over 2. Like in the numerator, a 3, an x, a y squared, and then the denominator, a 2. Would you like me to do number 20? Okay, here we go. So, we can do 20 any of the ways we've been doing things already. If the same thing shows up top and bottom, we can do some reductions. Or, there's all sorts of ways to do these questions. Or, I can simplify the mess that I have in the numerator and then start making some simplifications. I don't care which way you want me to do it. I'll do it either way. Benita, which way would you like me to do it? Cancellations? Okay. So is there anything that shows up top and bottom? I've got a yx squared and a yx squared. You bet. Bam, bam. There's nothing left in the denominator that has variables. So this xy squared here in the numerator has to stay there. And now I've got a 2 times 3 in the numerator and a 4 in the denominator. 2 times 3 is? And the 4 stays. This is a reducible fraction. 6 and 4 are both divisible by 2. Just because we're talking about exponents doesn't mean you get away with not reducing fractions. 3xy squared over 2. Dunsies. So when you've got that, you've got to simplify the numerical portion. Yeah. 18 or 22. Does anyone want me to do those? Oh, yes, you did. Okay, how do you want me to do it, Pevneet? No, I want you. No, that's not what I asked. I said, Pevneet, how do you want me to do it? Cancellations. Okay, cool. Is there anything I can cancel top and bottom in number 18? Pevneet. The p to the power of 2's. Cool. So in the numerator, I've got a 4 over. Now I've got a 3 times 2p. I can multiply the 3 and the 2 together. 3 times 2 is?
6.
And there's nothing going on with that p. And now what do I do, Pevneet? You reduce. 4 and 6 are both divisible by? Boom, boom. So I'm going to get 2 over 3p. Done. One way to do it. And then number 22. 22. Is there anything that I can reduce right off the bat? Yes.
Maybe just the y's, because there is no y to the power of 2.
Well, I have to have something matching to get rid of things. You can't just arbitrarily get rid of y's. Yes. The 2's. I have a 2 in the top and a 2 in the bottom. Bam, bam. Donesies. Okay, what else? Anything else? Or now do I have to start making some simplifications? Okay. Let's make some simplifications. Do I have anything with the same base? There's nothing in the numerator. Do I have anything with the same base in the denominator that I can start grouping together using our exponent laws? Benita says yes. Benita, what? Do those as individual pieces. Like individual bases. Either x's or y's or whole numbers. So the base is the x. So I'm grouping all the x's together. Okay? I've got one there, I've got one there, and I've got one there. And this is all just being multiplied together. So when I multiply, what do I do with the exponents on the x? Add them, okay? So 2 plus 2 plus is 5. So I'm going to get an x to the power of 5 down there. What else am I going to get down there? That's all my x's dealt with. 4 times 3 is 12. What else am I going to have down there? That's u dealt with and u dealt with. What else? I've got a y there and a y there. Again, they're being multiplied together. And a y there. So y times y times y is y to the power of 3. And now we're almost done. What can I do with this? Yes. What part? What do you mean?
No, never mind. Wait, I thought the y was a 4. My eyesight is not.
How do you get what? That's a y.
Oh, yeah. No, I'll bet it. Yeah.
That's also a y.
I thought that was a 4 for a second too.
My apologies. Those are y's. Is there any other exponent laws I can deal with here? Do I have any same bases top and bottom? Yes, Pevney?
Oh, wait. Like the y's, I guess.
Yeah, the y's. Is there anything I can do with this? No, I'm dividing. So when I divide I subtract. It's always top minus bottom. So 2 minus 3 is? And so that becomes the exponent on the y. It's going to be a y to the power of negative 1 over 12x to the 5. And at this stage, with what I've taught you, that is a totally acceptable final answer. With what you're going to learn next year, it's not, but this year it is. You'll learn another exponent law next year that will make this no longer correct. But this year, that's fine. There's only one more exponent law you learn next year. Okay, are we cool with these? This class has like a half an hour left, Mr. Minocha? Okay, here we go. Let's learn fast. Okay, here we go. So, powers of powers. Let's do it. So when I have a power to a power, what does this mean? I've got 2 cubed and then in brackets squared. What does that mean?
It's times.
I didn't ask what the rule was. I'm asking what does it mean? Benita.
2 cubed plus times 2.
So close, but no. Yes.
So do whatever's in the brackets first and then times it.
No, we are not doing that. I'm not making 2 cubed 8 and then 8 squared is 64. Not happening. The whole point of the exponent laws is to be able to write these things as simplified exponents, not to evaluate them. So what does it mean to square something? Squaring something means I multiply it by itself. How many times? Squaring something. I'm squaring. I'm squaring 2 cubed. So this is going to be 2 cubed times 2 cubed is what this means in expanded form. 2 cubed squared means I have 2 cubed times 2 cubed. Whatever you're squaring needs to be multiplied by itself. Yeah? No? Which part? Sorry? Okay, what if I had this? What if I just had 3 squared? What would that mean? What does that mean? 3 times 3. What if I had x squared? What would that mean? X times x. What if I had Smiley face squared.
smiley face.
Maybe smiley face times smiley face. What if I had Benita? And I squared Benita.
And Benita times Benita.
I'd have a Benita times a Benita. How the heck would I do that? I don't know. It doesn't matter what you're squaring. It all means the same thing. You take the thing and you multiply it by itself. So in this case, what I'm doing here is I'm taking something that's already has a power, 2 cubed, and I'm squaring it. So work your way in from the outside. If I have 2 cubed squared, that's the same thing as 2 cubed times itself. So 2 cubed times 2 cubed. Does that help?
Yeah.
Okay. Now, there's an exponent law that we can apply from yesterday. When I multiply the same bases, what do I do with the exponents? Add them. Okay, cool. So 3 plus 3 is 6. But look, could I have done anything to get from the first step to the last step without doing this? How can I use 2 and 3 to get 6? I can multiply them. That's the beauty behind multiplication. It gets rid of repeated addition. So instead of going through this middle step, I could just say, oh, look, 2 times 3 is the same as 3 plus 3, 6. So if I just multiplied those two numbers together, we would have gotten to the same ending spot. Zoom this in here so we can see a little better. Let's try the next one. What does it mean to have 5 squared cubed? Pavni. It is 5 squared times 5 times 5 squared. Cubing something means I'm multiplying it together 3 times. And when you multiply something together 3 times, well, you just, multiply it together 3 times. No, some comment for that, man. That was not a great time to go. Middle of a lesson with a short block. If you can hold it, I would like you to try. And now I'm multiplying a bunch of things together. 5 squared times 5 times 5 squared. The bases are the same. When the base is the same, what can I do with the exponents? Yes. Add them. What's 2 plus 2 plus 2? But oh look. What could I have done with the 2 and the 3 here to also get 6? I could have multiplied them. Are we seeing the pattern? What do you expect this one will be? Yes, Benita. X to the 8. Let's prove it real quick, shall we? Squaring something means I multiply it by itself. So it's going to be x to the 4 times x to the 4. When I multiply the same bases, I'm going to add together those exponents. 4 plus 4 is 8, and the base stays. So you're getting are we seeing where this is going? When I have something to an exponent in brackets to another exponent, we're going to multiply the exponents together. So the power of powers rule is multiply the outer exponent with the inner exponent. With the inner. So then what do you think that last one should be? Yes. Sorry, Manraj. Y to the power of 35. Good. You betcha. That's the first rule we're going to look at today. Next rule. I'm going to do all the rules and I'm going to put you to work on them. The power of a product means you're taking something, you're multiplying it together, and you're putting that thing to a power. The rule is going to look very similar to what we did before. I've got 2y cubed in brackets, bless you, all squared. Earlier, you told me to square something means to multiply it by itself. So what is 2y cubed squared? What does it mean to square something? Pavni. Yuvraj, face on the screen. Because we're going to screw this up and When you spend time in class talking to other people while I'm trying to give you a lesson, and then you're like, I don't know what's going on. I don't want to help you.
I read that wrong.
What does it mean to square something? Squaring something means you're going to multiply it by itself. So if I've got 2y cubed squared, what does that mean when I expand it out? Yeah, well, I mean, maybe I said it wrong. 2y cubed times 2y cubed, yes. So I'm going to get 2y cubed times 2y cubed. But I can rearrange the order on that, right? When I got a bunch of things multiplied together, I can just move them around. The multiplication will still work. So I could rewrite this as 2 times 2 times y cubed times y cubed. This time, just to prove a point, I'm not going to evaluate anything. How could I rewrite 2 times 2 as 2 to some power? Pavni, 2 times... Yeah, 2 times 2 is the same as 2 squared. What's y cubed times y cubed? Pavni? Yes. And take a look at what we've done here. When I've got an exponent on the outside and a bunch of things multiplied together on the inside, what happened? That exponent 2 got applied to the 2 out here, and it got applied to the y cubed. That 2 hopped in here, that 2 hopped in here. And it multiplied with whatever exponent was already there. Y to the 3 times y to the 3 is y to the 6, and 2 became 2 squared. That exponent on the outside applies to everything multiplied together on the inside. Shall we do another? Yes, Benita.
So we could write it by like 4 by y to the power 6. Can we write it like that?
If I asked you to evaluate it, then you would say, yes, this is 4y to the 6. Yes. Okay. Next one. I've got x squared, y cubed, in brackets, all squared. What's that going to happen? Take a look at what we just did. Someone predict what's going to happen. Are you dying?
I think I know about it.
Then say.
X to the power 2 multiplied by x to the power 2 G3.
If I'm expanding it, yeah, I can write it like that. When it was squaring something, it means I take the thing and I multiply it by itself. But look what happens here. When I've got x squared times x squared, that's going to give me x to the 4. Y cubed times y cubed, because those bases are the same, I'm going to add those guys together too. I'm going to get y to the 6. Look where we started, though. I have x squared y cubed, in brackets, all squared. What could I have done to avoid writing this guy out? Yes. Yes. Multiply the outer exponent onto the exponents on the inside. X to the 2 times 2, x to the 4. Y to the 3 times 2, it's y to the 6. Love it. Beautiful. Next one. This one's a little bit different. How's this one going to behave? This one, and I'll just start telling you these things. Here we go, for the sake of time. I've got negative 2x squared, in brackets, all cubed. So that exponent on the outside is going to get applied to what? Yes, it's going to go on to the negative 2. And it's going to go on to the x squared. To make sure it gets applied properly, what do we need to do to that negative 2? Think back to day 1. No. I'm applying an exponent. I'm not multiplying negative 2 by 3. When you have a negative exponent, if you want the negative to be included, what do you have to do to the number? I want the minus sign to be included. So we had to do something on that very first day. We had to make sure. Where is it? What did we have to do to make sure that the minus sign was included? We had to throw inside some brackets. So when you apply it like this, what we're going to do is we're going to take that -2, we're going to throw it inside a set of brackets, and we're going to apply that exponent to it. And then the 3 is also, on the outside, also going to get applied to the x squared. That's going to become x to the power of what? What do you do when you've got a power to a power? You multiply them. 2 times 3 is 6. And now if I told you to evaluate this, what would we do? What is -2 cubed? -8. -2 times -2 is +4, times -2 is -8. Good. So you get -8x to the 6 if I asked you to evaluate that thing. Cool. Last one. Someone take a guess at what that should be. Not a guess. An educated suggestion. Benito, is that a hand?
4x to the power of 6 and y to the power of 14.
You're so close. The x to the 6, y to the 14 is absolutely perfect. What are you missing? Nope. You need to make sure that that outer exponent gets applied to everything on the inner exponent. You applied it to the y, you applied it to the x. What didn't you apply it to? The 4. So this should be 4 squared. X to the 6, y to the 14. You have to make sure you apply it to everything. So you multiply, here we go, multiply, when you have a power of a product, the outer exponent onto each, and I want you to write each in big capital letters, each inner exponent. Next one. This one we've kind of already done. But we're going to make it gross. What happens when you put a fraction to a power? Say that again? Yeah, so if I've got 2/3 squared, it's going to become 2/3 times 2/3. Well, that's just going to be, for those of us who might be shaky multiplying fractions, I just multiply across the top. I multiply across the bottom. 2 times 2 is 2. Yes, but it's also 2 squared. 3 times 3 is 3 squared. Yes, and then if I asked you to evaluate it, you could. You would tell me that this is 4 by 9. But what I want you to see is this middle step here. Look at what happened. I had 2/3 in brackets squared. And then what happened? The squared got applied to the thing in the numerator and to the thing in the denominator. Guy went up here, guy went down here. What's going to happen down here? Next one. If you had to take an educated wondering, what would you wonder that it might be? Have neat.
Do you multiply the inner exponent by the outer exponent by the inner exponent?
Oh, that's what we did here. This law is a combination of these two laws and applying it to fractions. So the fraction says if I've got a fraction, I need to apply the exponent to the numerator and the denominator. And when I've got a power to a power, what do I do with the exponents? Multiply them. So then this thing's going to become what? Forget the expanded form. Let's go straight to simplified. This 2 is going to get applied to the numerator and the denominator. So in the numerator, we're going to have
4. 2 squared.
2 squared over
3 to the power
3 to the power of
of 6.
6. Which we could evaluate if we wanted to, but I don't really want to because 3 to the 6 sounds like it's going to be a big thing. Are you dying? Like, do you really have to go super bad? Okay, fine, then go. Okay. The only difference with this one is what? It's got the negative. What do we do with minus signs and fractions? What did I recommend you do every time? Bring it to the numerator. So what we're going to have here is we're going to have negative x squared all over y cubed, all to the cubed. The problem with this question, which is different from this one that we did, is here I had a negative 2. This is just a minus sign. So what could I do with that minus sign to actually give me a number to work with? Multiplying by, or having that minus sign there is the same thing as multiplying by what? Negative. What number? Pevney? Negative 1. So what I want to encourage you to do, at least at this stage, is actually force that negative 1 in there. Yeah? Oh. No? Okay. Thought you had a question. And now once we've got the negative 1 in there, I can apply this exponent to each piece. I'm going to get negative 1 cubed. I'm going to x to the power of what? What do I do when I've got a power to a power? So 2 times 3 is? So it's going to give me x to the 6. I have to apply the outer exponent onto every piece, numerator and denominator. What's going to happen in that bottom one? It's going to be y to the power of what? Yes. Someone said 9. Y to the 3 times 3, which is 9. I could simplify this a little bit, I suppose, if I wanted to. Because what's negative 1 cubed? Negative 1 times negative 1 is? Times another negative 1 is? Negative 1. So this would just be negative 1 x to the 6 over y to the 9. You can evaluate that number part, actually do this part, and get that. The next one's going to look very similar. Take a look at the one we just did. Someone walk me through the next one. What's going to happen? Have neat. Bring the negative up to the numerator and make it? Yes. So we're going to put a negative 1 x squared over y cubed all to the power of 4. What are we going to do with that?
Multiply the outer exponent by the inner.
On every piece, numerator and denominator. So I'm going to get negative 1 in brackets because it's negative. I want to make sure that negative gets included. You got to put it in brackets. It's going to become negative 1 to the power of? Negative 1 to the power of? 4. That 4 needs to apply to each piece. Draw the arrows if it helps. Make sure it goes everywhere. It's going to be negative 1 to the 4, x to the power of? 8. Good, because you multiply when you've got stacks of powers. And then in the denominator, I'm going to have y to the power of? Good. And there's one more simplification I can make here. The x to the 8 is going to stay. The y to the 12 is going to stay. What's going to happen to that negative 1? I mean, is it? Why? Why is it going to be a minus sign? I don't know, is it? If it's going to be positive, why is it going to be positive? Because you've got an even exponent. So negative 1 times negative 1 is 1, times negative 1 is negative 1, times negative 1 again is positive 1. I have 4 negative 1s being multiplied together. So that's going to turn this whole thing positive. And when it's positive, it just is gone. We don't need to put a positive 1 there. This would be your final answer because we have an even exponent. So the power of the quotient rule is this. We want to apply the outer exponent onto everything. Technically, 1010 says you can't go. Sorry. The numerator and denominator. Oh, man. Oh, not enough space for all the words. Well, one more law today, and then we're done. Yeah, but it's an easy one because you've already seen it. When you're ready, flip the page. I won't flip the page till all of you are ready. Okay, last one. When you're ready, flip the page. Last one's the easy one. Zero power rule. We've done it already. You've seen the chart. Anything to the power of 0 is 1. Straight to the bottom. This is the rule. Anything to the 0 is 1. So we're just going to crank these out and tell me what they are. 2 to the power of 0, 1. 2 times x times y, all to the power of 0. 2/3 to the power of 0. X to the 0 plus y to the 0. No. Ha ha ha. It's 2. Why is it 2? X to the 0 is?
1.
Y to the 0 is?
1.
And then you got to add them. It's a sneaky one. And now I've got 2 more to toss here on the bottom for you. If I've got -2 to the 0 and then -2 in brackets to the 0. What's the bottom one? -2 in brackets to the power of 0. Anything to the power of 0 is 1. So -2 in brackets to the power of 0 is? It's 1. Because anything to the power of 0, and this negative is fully enclosed in brackets, be 1. Well, how is this one different? It's not in brackets, which means the minus sign is not included with the exponent. So you would have to go 2 to the 0 is? Well, I'm trying to break it up here, but yes, that's the final answer. 2 to the 0 is 1, and then you multiply on that minus sign out front. So without the brackets, this is -1. With the brackets, it's +1. And I'm done. This page summarizes all the things. Flip it over. There are, I want you, for your homework this weekend, there are 30 questions. I don't want you to do all 30. I just want you to do numbers 1 to 16. See what happens. Do your best. This page 8, numbers 1 to 16. See what you can get done for homework. And we will go. Actually, no, I lied. Open your work back up. We're going to fix this. I changed my mind. I want you to do, it's the same number of questions. There's actually less questions. I want you to do 1 to 30 odds, which is 15 questions instead of 16 questions. It's actually one less. Do 1 to 30 odds. And then on Tuesday, we'll take those up and spend some more time practicing. We don't school Monday. It's Thanksgiving. 1 to 30 odds is what I'm going to get you to do. There you go. Have a great day. When the bell goes, you may also go.